how SAP goes about doing security tests within the company and how to enable developers to act as security testers.
Exactly.
Okay, the floor is yours.
Thank you very much for the introduction. So just as a short background, SAP is a vendor of business software. It has over 60,000 employees. More than a third of that are actually developers. So development software and development locations are distributed worldwide. The largest location is still in Germany, but we have big locations in China, in India, in Eastern Europe, in the US. So it's really a global company. And for myself, I'm working on our security testing strategy for the software development. So how do we do security testing within the development? I also act as a researcher, and I'm working in the central security team that, for example, also designs our software development lifecycle. Also as kind of a background, because I think it explains why we are doing things differently than other people. For example, we differ from the OWASP SAMM model. We differ a little bit from Microsoft's proposal about the security development lifecycle. We have a rather decentralized development culture in our company. So we have a central security team, or a team of central security experts. That's it's one team defining the software security development lifecycle. It organizes the security trainings. It defines our product standards, so what are, so to speak, our OWASP top 10 equivalent. It defines risks, risk assessment methods, threat modeling methods. It defines the security testing strategy. That's my part, for example, where I'm concentrating on. And it selects the security test products used within the company for the development area. Then in each development area, we have local security experts. That then depends on how the local team organizes themselves, how many experts they have per developer. If this is a full-time job or if there's several people doing, so to speak, job sharing as a security expert, they support locally development teams in security activities. And development teams themselves, they are rather empowered. They can select whatever development technology they want to use in certain boundaries, but in principle they have much more freedom than in many other large companies. And they also select their local development model, so they have development teams which are already on a very cloud-based and agile development model with multiple release cycles per day, but we also have very traditional software development, and we as a central team have to serve them all. As motivation, why are we looking at software security at all? Here for this audience, I think it's pretty clear. This is the distribution of vulnerabilities over the last 15 years that were made public as CVE entries. And we see here the programming-related issues, the non-logical flaws, like code injection, overflow issues, SQL injection, cross-site scripting, are still on a pretty high percentage of the overall CVE values. So we still have a problem in the industry of getting software systems secure from a coding base. Let's look on an old study from software engineering. That's from Casper Jones from 1996, where software bugs actually occur in the software development lifecycle. And I don't want to argue about the numbers that are put on that graph. It's about the tendency. It's pretty obvious that most bugs and also most security-related bugs are actually created when we code, when we implement the system. Fewer security problems are actually created by configuration issues when we deploy something. Most are definitely in the coding phase. On the other hand, if we look how much it costs to correct the bug, that's very cheap in the coding phase, so that's the red curve here, and very expensive when the software is already released, when we need to patch and downfall fixes. And if we look, and as said, that's already 20 years old here, when actually industry fixes defects, we see that most defects are fixed rather late in the software development lifecycle. So it's stages where they are rather expensive. And that should not happen. That's why we have an intrinsic motivation to shift testing as early in the development lifecycle as possible and start with testing when we also start with coding. We heard already several talks today that a secure development lifecycle or a security development lifecycle is important. And one of the first ones that was published, I think it was actually the first one that was at least widely accepted, is the one from Microsoft. And that's also something we got a lot of inspiration from. It's a very good one, actually. We need to have training, requirements, bring security in the requirements engineering phase. We need to do security design. Then the implementation phase is, of course, very important. That's where the bugs actually are created, where the security problems really occur. Then we have a verification phase, a release phase, and the response phase where we are handling bugs that happen in the field when the software is deployed. Our software security lifecycle looks differently, and I will explain the differences after a few slides that I show what we're actually doing. But here you see already it also looks like there's implementation and there's verification, two separate steps. And that looks like the model before. We first code, and then we look if the code is correct and start fixing bugs after we implement it. And that's what we want to avoid. So actually, what are we doing and how did we start? We started with static analysis in 2010 globally. So since 2010, it's a mandatory technique for all products being developed at SAP. Regardless of the technology used, regardless of the shipment model. So if it's a cloud product or on-premise product, don't care. A static application security test needs to be done for the product. And we are using various tools. I think all of the vendors are also here and have tools besides our internal tool for ABAP, which is an SAP proprietary language. But you see already the tools work differently, have a different quality for the different programming languages, and therefore we use multiple of them. And we constantly look at the usage and improve that. And that's a very good baseline because static analysis can be applied actually when I start to write the first line of code. So, looks good. Problem solved, right? Sadly not. Static analysis cannot find all the bugs, all the security problems in our software, and also it does not work equally well for all types of vulnerability. So it clearly has advantages, but it also has limitations. It heavily depends on the programming languages being used. So for example, 2-3 years ago when JavaScript was becoming more and more popular, we had big problems because none of the static code analysis tools delivered the quality we were happy with for JavaScript coding. So there was a big white spot in our static code scan strategy at that point in time. And it usually only covers one layer of an application stack. So here on the right-hand side, I have a very abstract architecture of a modern business application. We have a client application, a rich client, for example, running on a web browser, which would then run again, of course, on the client side of an operating system. We have the server application running in an application container, and we have some backend systems. And what we can cover very well with static analysis is one of those layers. So if we recall how we are using the tools currently, we most likely will use check marks for the JavaScript part running in the web browser on the client side. For the server application, for the Java part, we will use Spotify, and for the C++ part, Coverity. But there are still large areas uncovered, and none of the static tools really test the combination out of the application and the underlying web browser. So the security problem only occurs when I combine multiple of those layers, multiple tiers of my multi-tiered application. I usually will not find it with static analysis. That's where dynamic tools are really good at, like HP Web Inspect or Dominator, which is a smaller tool dedicated for cross-site scripting vulnerabilities. They really run the application as it is in the whole environment. So I cover also the operating system, the network configuration, everything, and can really test through the whole stack. And of course, if I'm combining static and dynamic analysis, then I can also start to use the static tools more selectively. So for example, if I use Dominator for cross-site scripting and have HP Web Inspect running, there might be certain vulnerabilities found by checkmarks where I say, yeah, actually the dynamic tests have a better quality, so I don't look at those static findings. So I reduce my effort there, and maybe I say, yeah, the C++ part is covered well by the dynamic tests, so for that product, I don't even use Spotify, so that the overall effort then can be, is not that significantly higher compared to only using static analysis, and I still cover a larger part of my application. Of course, there will always be areas that I do not cover. That's just too much effort. So the question is, how do I actually select those tools? How do I come up with a strategy for a specific product? Which combination of dynamic and static tools should I use? And for that, we are using a risk-based approach. We have our own risk assessment method called SecureRIM, but the same principle applies if you're using, for example, OWASP ASVS. So there are some differences in the methods, but the principle itself is universal. From that risk assessment, we infer a prioritized list of SAP security requirements. SAP security requirements, that's our product standard security. That's a list of security requirements like SAP product shall be free of cross-site scripting, shall be free of SQL injection. So think about like the OWASP top 10, specialized for SAP products. And from the risk assessment, I also get a priority, like for this specific product, SQL injection is a very high risk, cross-site scripting is a lower risk. For example, if I'm implementing the server component, then most likely cross-site scripting is not very relevant. So it's also not very influencing on the selection of security testing tools. I also get the implementation details, like which programming languages I use, which frameworks I use. So is this, for example, a server component using Node.js and Express, then I will use different security testing tools compared to a Java application running on Tomcat. And also the application type. Is it a mobile application, cloud application, client-server application influences the selection of tools. And based on this information, we infer a product-specific security test plan, which then describes which security test techniques are used for the different components. And for example, this is a really only an illustrative example, that's not a real test plan. I have a very simple application on the left-hand side. It's a small mobile application talking to a back-end server. And here, for example, I could assume that from the risk assessment, the first risk I identified is that an attacker might inject JavaScript code into the mobile application. And then I see also from the implementation technique, we are using only UI5 controls. That's a programming guideline. UI5 is a framework developed by SAP, and luckily that framework already has all kinds of checks for injection in the print and in the framework. So if the programmer adheres to certain programming paradigms, they are already secure. So that allows us to statically check the JavaScript part. Even though JavaScript is usually inherently hard to check statically, because we can check for coding patterns and insecure usages of our own API. For example, another risk I can see is that the SSL connections are not configured properly, that, for example, invalid certificates are accepted by the solution. That's usually something where static code analysis is not very good at. So here I come up with an additional manual test doing dynamically checking that invalid certificates are not accepted. And this test plan needs to be executed during development. And after development, I update this test plan or convert the test plan into a test report, documenting the results of the tests, and also in many cases giving effort estimates so that we can improve our own methodology and see where the actual effort is required. And sometimes there are also cases that issues are not fixed. We are living with them because we say the risk is acceptable compared to the business risk of not shipping the software. That's what we already heard in one of the keynotes this morning. The security department should not be the department that always says, no, we are not allowed to ship the software. Of course, if you do not ship software at all, the risk of security vulnerabilities is zero. But we also will not make any revenue, which then impacts also our existence. So let's look at our security development lifecycle that we came up with. And we also start with training. That's pretty obvious. Risk identification is also an important part. That's where the security requirements are also inferred together with a priority. Then we have the planning of security. This is, so to speak, the preparation phase. This is in a traditional software development lifecycle, the part where I'm designing the software. I do not yet start coding. when I start to plan the actual coding activities, I need also to plan the security measures. And the security test plan I showed is one part of those security measures. So the development teams really need to accept that security costs effort in development and need to plan for that effort. Then we have the secure development, which includes, as the Microsoft security development lifecycle, static code scans and code reviews, but we also have a box there called security testing. And that's, for me personally, the big important difference here. We have security testing as part of development. It's not a separate activity. In addition, in the transition phase, which is the phase from the development team declares the product to be finished until it is shipped to the customer, we have a security validation phase, which does an independent security assessment. That independent security assessment executes usually also additional security tests. I explain in a second in a little bit more detail. And then at the end, of course, the security response process for products being deployed at customer side. Then we need to react and review on bugs that are found by external security researchers or our customers. So why do we have testing and validation? What I explained beforehand are the security testing activities executed by our development teams in the development phase. Security validation is a central team again that acts as a first customer. It's not a replacement of the security testing during development. That's why I'm also opposing again, we are developing, and at the end of the development we are making a pen test. Security validation might make pen tests, or they're doing pen tests, but they're acting as a first customer. What is the security experience of the customer installing and using an SAP product? Validation checks actually mainly the implementation of our security development lifecycle and less the security of the product. In an ideal world, validation wouldn't find any flaws in the product because the development teams have the products developed securely and already tested thoroughly. That's of course not true. There are still issues also in an ideal world that cannot be detected by development, so issues that are related to insecure configuration, where you need really to install the whole system. In particular for large enterprise systems, this is a challenge, and not each and every development team is able to set up the whole product being developed if they are only developing parts of it. So this interplay between different components can only be tested by validation. And also documentation issues, are the security guidelines documented properly, is something that validation only can find. Note, there's a third kind of security tests that belong to a full secure software life cycle. These are security tests, mainly then penetration tests done in the productive environment after installing an on-premise product productively or on cloud configuration, so testing the actual cloud or hosting offering for a provider. That's again something different. That's also not replaced by validation, neither it is replaced by security testing and development, because these after development and after deployment security tests can then really test the actual productive configuration, including, for example, the network environment. Is the firewall configured correctly? Here I also might have installed a web application firewall, which is part of the landscape that is tested. So there is at least 3 types of security testing techniques or areas for security testing in a software development lifecycle. So we are doing a lot of activity, and of course one of the questions is, how do we measure success? Measuring success for security activities in software development is always a difficult question. And in particular for security testing and development, we came up with the following considerations. We analyze regularly, actually on a monthly basis, because we have a monthly security patch day, the vulnerabilities reported by security validation, as well as the vulnerabilities reported by external security researchers or customers. So what is actually found when our software is used in the field? We analyze those issues, and in principle, there are 2 possible cases. First, the reported issue is of a nature that it cannot be detected by our tools. It is not detected by our current tool offering that we offer to development. The other option, of course, is it can be detected. The Let's go in more detail to the first case. Assuming this type of vulnerability that is not detected by our current offering and security testing tools. Again, there are in principle two options possible. It could be a vulnerability that can in principle be detected by the tools or techniques that we are currently offering to development. Then we need to improve the tools. Either it is a tool configuration, which we can do ourselves, or we need to approach the tool vendor and ask for additional features. So for example, I think 2 or 3 years ago, HTTP word tampering was this kind of attack. Occurred out of the blue, none of the static code analysis tools detected it, but it is a type of vulnerability which can in principle be detected statically, so we needed to improve the configuration, and we had a dedicated project for that. Logical flaws, for example, so this typical example, I have an internet shopping application, and I can go shopping without actually paying the goods I'm shopping. That's something which can only be understood if I know what is the business purpose of the application. That will not be recorded by none of the automatic, static, or dynamic tools. There we need to come up with other tools and methods how to find those issues. If the second case, so if there's a vulnerability reported that can be detected by our security testing tools, again we need to ask ourselves, why did it slip through the process? Where was the actual root cause that this vulnerability was in a shipped software product? The first case is a rather easy one. Our software has really long maintenance cycles, 10, 20 years. So we have customers which are still working on software that was released 15 or 10 years ago, where we didn't have these thorough security testing techniques applied. So today, this type of vulnerability wouldn't be shipped to customers. Okay, that's happening, but hopefully the number of these kind of issues will reduce dramatically when customers upgrade their system. If it's a vulnerability in a rather recently released software product that could be detected by our tools, we need to analyze why we missed that vulnerability. That could be that somebody misclassified the issue, thought, yeah, there's an issue, but it's low risk, and it is high risk. These kind of mistakes, of course, occur. We are all human, and human are making mistakes, but we need to analyze it and understand if we have a principal problem there, or if it was just an accident. And we are doing this kind of analysis. And the actual success criteria is that if we look at the number of vulnerabilities being reported in a fixed time frame, let's say within 1 month, the number of, or the percentage of vulnerabilities that is not covered by our tools should increase over time. That means for the type of vulnerabilities that can be detected by our tools, the percentage should decrease. So for example, the likelihood that tomorrow somebody finds a SQL injection or a product should decrease over time dramatically because we are testing very good for SQL injections. And that's the type of success criteria we measure ourselves against. Simpler criteria like the number of reported issues, number of issues reported by external security researchers is hard to judge because we do not have no control over the activity of external security researchers, and it could just be the case there's summer parade, everybody is lying on the beach, nobody is doing external security research, so nothing is reported. And in the long winter months, when everybody is sitting at home, we got more reports, so that's not really something we can scientifically measure that we are getting better. What are the lessons learned from using this multiple-stage security testing approach at SAP? The key success factor, of course, is a holistic security awareness program for developers, for managers, for everybody in the company. We heard that always, yeah, hearing that always. Security awareness is the big problem. Developers don't understand security. We need to make them aware that security is an important topic. Yes, security awareness is important, but developer awareness is even more important. The really hindering factor is the missing developer awareness by the security experts. And that's something which we really need to tackle. The key success factor is really listen to your developers, understand why they implement software not as secure as we would like them to implement them. Why are they making mistakes? I believe that there is no developer that wants to implement insecure software on purpose. They want to implement secure software. But it's so much more difficult to build something securely compared to finding an attack in the software. It's much easier to destroy a house compared to building one that is undestroyable. It's not just building an arbitrary house. We ask them to build an undestroyable house. And you cannot expect your developers to become penetration testers or security experts. That's not their job. Their job is to build good, high-quality software, and high quality means reliable, but also secure. So we need security testing that is consumable by developers. So we need security testing tools for developers that need to be applicable right from the start in development, that automate the security knowledge. That doesn't need to mean that they need to be fully automated tools, but most of the security assessment needs to be automated. A developer has usually not a big problem in executing a security test tool. They are doing it anyhow for functional tests. They are running JUnit tests. They are also willing to do some interactive tests. No problem with that. But if they need to understand what is cross-site scripting, how to inject, to modify HTTP headers to use a test tool, that's most likely not the right test tool for a developer, because it requires additional security knowledge. And that security knowledge needs to be encapsulated in the tools. And we need to make them consumable, easy to consume. They should be so easy to consume that it feels morally wrong not to use them. Build them in the IDE, instant feedback, for simple things like hard-coded password or using insecure APIs like Java, util random. I mean, just when I type that call, it should be underlined like doing a spelling mistake in Word. Tell people directly, immediately, it's not a good idea to use an insecure random generator. There's a good alternative. It has the same API. You just need to replace the import statement at the beginning of your Java code. And we also need tools that nicely integrate into continuous integration environments like Jenkins. They can do more in-depth analysis because they don't need to provide instant feedback, but they also need to provide feedback within 8 hours or so, that an overnight check is possible. And we need to provide easy to understand fixed recommendations. We've seen in one of the keynotes today these nice explanations from Stack Overflow and other websites how things can be done securely, how things can be encrypted using base 64 and stuff like that. You don't want your developer to find these kind of solutions in the internet, so we need to provide them with easy to understand, clear recommendations what to do. And also we need to be clearly what are the sweet spots of the tools. Sometimes tool vendors or also we as security experts claim that a security testing tool can find all SQL injections. That's usually not true. They have their sweet spots. They work for certain frameworks, certain architectures. The tools work very well, for others they don't work well. Make this transparent so that people can select those tools that work well on the products they are developing, or that they are aware that they're developing in a space where we cannot offer good automated tools, and that they need to do manual code review, integrate pen tests, more pen tests, because they cannot rely on these automated tools. And finally, collaborate with your developers. We as security experts need to collaborate with development. We need to create more easy to use APIs. Who has ever tried to use an SSL API securely? It's a tremendously hard task. And we are seeing more and more reports that none of the mobile application is validating certificates. Whoever tried to implement certificate validation on Android in the test environment, where I need to disable all the checking so that I can use self-signed certificates, and then switch to a production environment, understands how easy it is to forget to enable the validation again. We need to think about solutions that makes it much more easier to test and develop security features of our software in a test environment. and to design APIs that make the secure usage of the API the default, make it hard to implement something insecure. The default needs to be the secure API. And we also need to help the people that design programming languages and frameworks to do the same. It should be hard to implement insecure systems. And we need, of course, to explain how to program securely. For a programmer, yes, it's nice to understand how an attack works. It's nice to understand what cross-site scripting is. But an explanation of cross-site scripting is helpful for people that are interested in security already. If I'm a developer who only says, yeah, the system should be secure, I don't need to be able to distinguish cross-site scripting, reflective cross-site scripting, stored cross-site scripting. There's a problem, the security expert says it needs to be fixed, or I should not implement this problem, so please help me how to do it right. Even if I don't understand the details what cross-site scripting is. Just help me to avoid it. That's what we need to do for our developers. And yeah, conclusion, before we come to the question and answer session. Secure software development is a prerequisite also for secure operation. So if you're not doing on-premise software development but cloud development, even with fast release cycles, and it's much easier to patch your software, you need to develop your software securely. And these abstract security software development lifecycle I've shown, we also apply them to an agile development framework, where we have just a slightly different representation of it to making this fast development cycles more visible in the representation. But it's the same steps in there, the same tasks that need to be done. Secure software development is also an important mitigation strategy for the risk of operating and maintaining IT systems in general. We need to have an end-to-end approach for security, starting by training developers doing security testing during development, the validation of the actions that we are doing in the final product, as well as doing maintenance and security patch management. And again, I cannot say enough. The developers are not your enemies. Developers are the most important ally with respect to implementing secure systems. So we should make life easy for them. That's really the important part. Thank you. I'm now happy for discussing the topic, answering questions. Let's start. I must ask to give you the microphone.
Sure. I'm glad to see that the way you've set this up, I was just wondering how much did you align your tools with the tools developers are already known and work with, things like automated building and automated testing frameworks that are already there?
We are aligning that. So, for example, we are working on, we have an enterprise GitHub license within our company. So we're integrating the testing tools into GitHub so that if you create a project on the GitHub server, the project is automatically also created on the management servers for the security testing tools. There's still a lot of improvement possible, but we are working to make it as easy as possible to integrate that, and we are also developing small security testing tools that are integrated into the IDE that give instance feedback to the developers that are not necessarily on the type of quality that you can do for a final security assessment of the product, but it helps already to avoid a lot of smaller mistakes right from the beginning.
This is not a question, it's more of a comment. From my experience, it is fundamentally important to also say from time to time what the developers do right. So to emphasize what they have done well, because this, first, they know next time how to do it well again, and second, you kind of, you make the relationship to your developers better. So I, as a penetration tester and someone who has to tell them or pick on them and tell them what they or how they have to could do stuff better, in my experience, it's very important to tell them that there is things that they have done well, actually.
Yes.
Just a comment, no question.
Fully agree, positive feedback is important as well.
Thank you very much for sharing your experience with this. And I had a question about two aspects of this. Forgive me if I missed it at the beginning. I came in a bit late. I'm trying to do the same thing in a large global footprint of developers. And I'm wondering how you handle the scale of global footprint of developers in terms of education and tool maturity usage. And then my second question is also, SDL is great and SSDL is great for new developments, but what about legacy? What's in already production? How do you catch that?
As our teams are using a large variety of different technologies, so we are not a company like, let's say, like Microsoft, which mainly develops on one stack. We have a decentralized model. We have a central security team working on those definitions, selecting the tools, configuring tools for our technologies, and then we have security experts embedded in the development teams that locally spread the knowledge to the developers, and we teach those decentralized security experts, the local experts, and they do then the teaching further to the developers. That's how we scale our security deployments. Maintaining old products, yes, that's a big headache. Don't apply the same security testing rules that you apply for new development to your product during maintenance. That creates a big mess. Because the code will have a different quality in your old product. So what we did is we started with selecting a few vulnerabilities. So we said these are very important for our products, and we look particularly at those, also in the old and maintenance code, and then try to widen this area step by step, but being fully aware that the maintenance code is a separate discussion. You also have less developer people for maintenance, and frankly speaking, if the product is already running since 10 years at the customer side, most likely the issues that have not yet been detected will not be detected tomorrow. You don't have to act extremely overreact. You can plan your development there carefully, most likely without creating too high risk. What is important though is if you update something in a new code base, which is publicly known, then you need to backport that also to the maintained code. Otherwise you put your customers on risk that still are on the older releases. So that also calls for slightly different treatment of vulnerabilities that are now externally versus the one that you detect in your internal security programs.
Thanks for the great talk. Would you say that it makes sense to implement security tests as unit tests? And if so, should that be done by the developers? Can they do that? Or should that rather be done by the security experts?
I'm in big favor of implementing security tests also in unit tests, also in particular as regression tests. If I fix something that I don't reintroduce the same bug. But that's definitely not the only type of security test that we do in development. If this should be done by a security expert or by the developer, I think that's a personal decision of the people working there. I know developers which are very good security people as well, or at least understand which test cases they need to use, then they should do it. So that's something which you need to decide locally if you have your Scrum team, for example. I cannot give a general recommendation there. I mean, the other point that I can say there is it really makes a big difference if somebody volunteers to be the security expert in comparison to somebody that was elected to be the security expert.
Thank you for your talk. I have one question. If you had to build this team right now, the security team, what skills would you be looking for exactly in these people?
in combination. You need to have the technical skills and understanding how the tools work, to what extent they can be improved, which is also important in your relationship to the vendors of those tools. But you also need the process experts that can define your overall processes. So you need really various skill sets there, so that it makes sense to have really a number of people working in that area. It is security expertise firsthand, but also a solid understanding how development works. So in particular for the security testing part, I prefer people that did software development for some time on their own. That they know the development tools, that they know or at least can feel the pain a developer has in using testing tools that don't give good recommendations how to fix something.
Thank you. You said that you have teams that are agile and extreme, but you also have classic waterfall. In your experience, do you see more problems in agile or not?
I cannot comment on that. Sorry.
Who is handling the static code analysis results? Who's processing or looking at them and decides if it's indeed an issue and should be picked up by the development teams?
That's the task of the local security experts. And then it depends on the local teams. I know that we have teams where really within this current team there's one security expert looking at all of the results, and the developers only have that security expert, so to speak, as an interface to the analysis tools. They just get reports in the whatever bug tracking system they use. And I also know that we have teams where each and every developer is able to execute scans and look at the results. I don't have numbers which of the models works better from an objective point of view. Personally, I prefer when developers have direct access to the tools, because anything that is fixed before a security expert or somebody that could be understood as a kind of controlling part of the process sees it, the better. I mean, I always come up with the explanation, if I program in Java and I forget a semicolon at the end of the line, the compiler reminds me to put it there, I put it there, fine. If the security testing tool finds issue, I fix them immediately. I don't discuss, does this need to be fixed or not, I do it. I, from a security expert, I don't want to have statistics of that. I don't care. I need to do a scan at the end to assess the quality, but if the developer in the meantime did hundreds of scans or none, that shouldn't be an issue. So if a developer wants to have access to it, he or she should have.
Okay, then you assume that there are a lot of false positives, so that somebody marks that's not exploitable because he lacks security knowledge, or?
I mean, that's something which we then would capture in our validation phase, and then we see that we need to re-educate people doing the assessments.
Other questions? Time for one more, I think.
Thanks for the talk. I find the bit about the organisational design very interesting. Is there any crossover between the people who are security experts on the teams and the people who carry out the assessments at the end?
No, the validation team is by design a separate team which is not part of the development teams at all. They are also free to use whatever assessment method they like to do. That's really like in the European political system, that the people designing the laws and controlling that people comply to them are separate.
Okay, I think we can wrap up. Thanks a lot for the talk. Please don't forget, people.